In this video, we're looking at quadratic equations in x squared plus bx plus c form. So a quadratic equation is an equation involving a variable that's squared, for example, the x squared. So again, an equation in which the highest power of the variable is 2 is called a quadratic equation. For example, x squared equals 5, 3m squared plus 7 equals 10, d squared minus d minus 6 equals 0, 4y squared minus 3y equals 8. These are all what we call quadratic equations. So we're going to look at solving your basic form of a quadratic, the ax squared equals c. So the quadratic equation x squared equals c has two solutions, and you need to take note of this very carefully. Whenever you have a solution where it involves a quadratic, you always have a positive and a negative solution. So if you might recall that if I have x squared, the opposite to that is the square root, all right? So our square and our square root, they're what we call our inverse operations. So whenever we need to get rid of a minus, remember we always plus. In the same way, if we need to get rid of a square, we square root. So if we have y squared equals 225, I need to square root both sides. So that would cancel that out, and I'm left with y equals the square root of 225. And at this point, you can put this straight into the calculator, and you'll get y equals plus or minus 15, because both, if I go 15 times 15, I get 225, and if I go negative 15 times negative 15, I also get 225. Hence why both the positive 15 and the negative 15 are our solutions. So here we have another one. Before we square root everything, I want to make sure I get the letter by itself first. So I want to do the opposite of minus 9, which is plus 9. So I'm left with t squared equals 7 plus 9, which is 16. And then I can do my square root, and I get t squared equals plus or minus root 16, which means it's plus or minus 4. So here we have another one, 3w squared equals 300. Now remember, if I have something such as 3w, this is the same as 3 times w, and the opposite of times is divide. So we're going to divide both sides by 3. I'm left with w squared equals 100, and now I can square root both sides. So w equals plus or minus the square root of 100, which is plus or minus 10. Now we're going to look at a little bit more complex quadratics. So these are in the form of x squared plus bx plus c equals 0. And we need to factorize these. And I have covered this in previous videos, which I'll link below. So if I'm trying to solve this quadratic here, remember this is my times number and this is my plus number. So I need to form a table where I have two numbers that times to give 2, but add to give 3. So my first pair could be 3 and 1. And then I'll say, well, that 3 and 1 over here, sorry, let me change that to a plus. Not 3 and 1, sorry, what am I doing? I meant 2 and 1. So 2 and 1, so 2 times 1 equals 2, so that's correct. And then 2 plus 1 is 3. So this was a very simple quadratic, and it was quite easy to find it. If you don't find it on the first go, it's okay, just try another pair of numbers. So now that I know that, I can say that my two numbers are going to be 2 and 1. So remember, when we factorize these down, my x squared plus 3x plus 2, this turns into x plus 2, x plus 1. Alright, so our two pairs that we had up here are now down here, okay? Once I've done that, my solutions are So if I want to look at them at individual parts, so what do I need? So if I get rid of these greens, what do I need to make this equal 0? And what do I need to make this equal 0? So in my green, this x needs to be -2, because -2 plus 2 is 0, which is good. And then over here, this x can be -1, because -1 plus 1 is 0. So you'll also notice that our solutions, my x equals -2 and my x equals -1, are opposite signs of our pair. Alright, so let me say that again. They're opposite signs. So if I had 2 and 1, my solutions will be -2 and -1. If I had a pairing of, let's say I had something like x minus 3, x plus 2 equals 0, my solutions would be x equals 3 and x equals -2. Okay, so you notice that they're the opposites. Okay, so here we have another one. I'll quickly draw a table. My times is up here and my plus is here. So my times is going to be -10 and my plus is going to be -3. So because I have a negative times, I know I only have one negative number. Alright, so I need to find a pair of numbers where one's negative and the negative number is the biggest number because my plus is a negative. Okay, so I'm going to try -10 and 1. So -10 times 1 is -10, so that's right, that's good. But -10 plus 1 is -9, which is not good. So that is not our pairing. I need to find a different pair. I'll try -5 and 2. -5 times 2 is -10, which is correct. -5 plus 2 equals -3, which is also correct. So when I factorize down my quadratic, so I've got x squared minus 3x minus 10 equals 0. This becomes x minus 5, x plus 2 equals 0. And remember what we said, if I break it into its parts, if I'm looking at this one, and I'm looking at this one, I'm looking at them two different things. This x needs to be the opposite of minus 5, which is 5, and this x needs to be -2. To end the video, we'll do a quick recap. Remember, here on your screen you can see a bunch of examples for what quadratics are, but the highest power needs to be a square. Alright, now remember, when you're solving quadratics you need to use inverse operations, and the inverse of a square is the square root. So remember, if I have something such as x squared equals 16, the opposite of that square is my square root, which cancels it out to get me x equals plus or minus 4.